Hello, my name is Destiny Black,
My name is Phat Dinh.
and this is the synthesis and extraction of endocrine disrupting steroids and the kinetic rates under varying external stressors. We first wanted to begin by talking about why we wanted to conduct this research. We were looking at birth control and saw that the two main components, which are progesterone and ethinyl estradiol, have negative side effects such as nausea, dizziness, and psychological effects that users have reported. So, what we wanted to do was find a natural alternative for the intake of progesterone and to synthesize a form of ethinyl estradiol that produced a birth control that was still strong enough to be effective in fight against pregnancy, yet weak enough to where it lessened the negative side effects the user experienced. This research consists of three experiments, the synthesis being a one-step synthesis of the desired triazyl, the second being a quantitative study, which is the extraction and quantitation of progesterone from an egg, and the last being the kinetic, which is taking both progesterone and the desired triazyl and studying the degradation under mimic human conditions.
As for instrumentation, we'll be using NMR to check our synthesized products. We'll also be using LCMS and GCMS for our quantitative and kinetic study. Currently, we only have our LCMS method due to the fact that our kinetic study is still ongoing. Nonetheless, our LC parameters is as follows. We're using a C18 column with the mobile phase being water and methanol. We also have additives such as ammonium acetate and 0.1% formic acid. We're using ESI in the positive mode, and we're looking for a precursor ion at 315.25 m/Z and a product ion at 97.
Next, we have the synthesis schematics, which is utilizing click chemistry. We begin with a copper catalyst, an alkyne, and an azide in order to create the desired triazyl. Next, we have the sample preparation of the quantitative study. In a 9-step procedure, ending with the analysis using LCMS, we conducted and extracted data that produced our progesterone peak from a chicken egg.
As for kinetic study, we're planning to use a salt concentration of 3 mg per mil, and this is due to the fact that a human body salt concentration is at this concentration. We're also planning on having the temperature at 25 degrees C and 37 degrees C, with 25 being the room temperature and 37 being the normal human body temperature. We plan on implementing a photodegradation study as well. Here is a graph from the literature, and as you can see, the purified water has a much slower kinetic rates compared to the seawater. As for results, currently we have a chromatogram of 100 ppb progesterone, as well as the external calibration curve of progesterone from 12.5 to 200 ppb. In figure 7, we have a chromatogram of our egg sample. Specifically, this is the egg yolk. We're able to compare this to our standard chromatogram to figure out that the first peak is our progesterone peak. Furthermore, we also compare this to our external calibration curve to get the concentration of progesterone in egg yolk to be 1.25 ppb, which comes out to 1.25 nanograms per milliliter.
Lastly, we discussed the conclusions and future works. We want to look at an NMR and an IR analysis of the desired triazyl to confirm it is what we made. We also want to look at a limit detection study for a quantitative experiment. As you can see, there is a 1.25 ppb, which isn't falling on the calibration curve because we didn't look at concentrations that low. Next, we want to generate a standard deviation calibration curve and study the matrix effects. Referring back to figure 7, as you see, there are other peaks in there, which are different components of the eggs. And we want to study how those affect the progesterone peak itself. And lastly, we want to look at the degradation in differing temperatures, salt concentrations, and as well as looking at the photodegradation study for our kinetics. We want to thank the AT program, UTA Department of Chemistry and Biochemistry, and all of our undergraduate TAs for their assistance in this research experiment. Thank you so much.